Hello, everybody. It is 5:33 p.m. Central Time on the 19th of October, 2020. It's Monday here in the United States. Hope you're doing well. Got a foggy, misty, cold, rainy day here at where I'm at in the New Madrid Seismic Zone in Missouri. But what's up to everybody up in Alaska? Let's get into this, guys. A noteworthy earthquake has struck up here at the Alaska Peninsula. We just premiered over on YouTube. I'm going to save this and go ahead and upload it to YouTube as well. Let me get a display capture turned on here so you can see what I see. Start over here. First of all, end of my update just an hour ago. No buoys in event mode. Now we have 7 buoys in event mode all the way along the entire plate boundary. Going from where the large earthquake is up here to the north. See where this red line is going southwest to northeast up off the coast of Alaska. Well, that's the spot, or at least the area, the region, if you want to call it that showed a shift or a movement detected on the buoys. Now, the buoys are detecting wave height, so we'll click on one, and we see a big disturbance here detected on the wave height. And let's go in and click on the event details, and it'll show us a close-up of it. Now, this is pretty much registering the earthquake with a rise after it. So I would think that rise would be the rising tide as normal, but the earthquake registering in meters now. This is in meters, which we got about 3 feet in a meter. We go from baseline, let's just say 4487 at a rough baseline where we started. And then it went up to 4489, almost 4490. Let's just say 4489. So we went from 789. We have a 6 foot or a 6 meter rise, which is 18 feet. So an 18-foot rise, and we are at least 100 miles off the shore. And let me show you where this is. So the buoy in event mode here. Again, we are far off the coast of the Alaskan Peninsula next to where the earthquake is. Let's go up here and pull it up on Google Earth. So our buoys are located out here along the edge of the ridge going down to the plate boundary, which was the red line I just showed you on the USGS map that goes in a curvature up towards Alaska. This is about a 19 or 20,000 foot drop off here. So think of this like a steep cliff that goes down. This is higher on this side. Alaska sits up at the top, and this is the very deep depths down to the edge of the plate boundary. And I just want to measure how far that is from where the rough earthquake epicenter is, all the way down here. So it's about 100 kilometers, or in miles, that's about 75 miles away. So 75 miles away from where the earthquake is, we've got the buoys out there, roughly. Again, it could be 50 miles, it could be 100 miles. But that far away, the nearest buoy is detecting that high of a wave disturbance. So let's go back and click on it again. Click on the details again. And again, we're in meters. We're going from 4487 roughly up to 4489. That's 2 meters, 6 feet. And that's big. Again, a big swell. And again, now we can go up to 3 meters, and that's more like 9 feet, 12 feet. It could be a big wave. That's what I'm getting at. Any way you measure it, whether you want to go in on the feet or the meters, it's the same conversion. We go out to the edge of this area, though. Let's go all the way over to the east. See, there's just a little tiny red blip. This is still measured in meters, but the blip is only just a few inches. Let's just put it that way. So, or a few centimeters. So, but that's on the far east side of the plate boundary over here where the red line is. So everywhere back behind it, as we go back closer to the epicenter, of course, as we go back closer, we're going to get bigger signatures that are on the buoy. So let's just go to one that's next. See, there's a blip, but the blip is just a little bit bigger. So what I would describe this as is the shaking that went out along the edge of the plate boundary, all the way as far east as, well, right in the middle of the area off the coast of Canada, and all the way west out to the pinnacle tip of the Aleutian Island chain. And let's go out to the western pinnacle tip of the Aleutians, or the central Aleutians, if you will, and see how big of a disturbance is registered out there. Oh, now wait just 1 second, guys. This is very interesting. A slight event mode on the downturn of the buoy. It looks like something happened here. This is a very odd event mode. So this, I guess, would be our baseline normal. And we have a drop 2 drops with no rebound up. What the heck? Okay, so this goes from 55.90 down to 55.75 and then comes back up to 55.90, then goes on again and it drops off again. We're talking 30 meters, 100 foot. What is going on there? I mean, look at the meters. Again, this is 55.90 is where our baseline is, and it drops down to 55.75. That's like 25 meters. It's just an insane drop-off. That's, again, in meters. What the heck is going on there? Let's go over and look at the next one over to the east. Let's look at this one. Let's go to the event details. Let's go in and look at... See, now this is tiny. This is a tiny little blip again. So what I'm seeing here is that on one pinnacle tip... Whoa, that's weird. What just happened there? On one pinnacle tip to the very far west, all the way out here at the westernmost point, we have this weird anomaly of, 25, 30, 40 meter drop. And then all the way over here on the eastern side, we have a little blip, which is just a few inches. Let's go up here at the pinnacle tip, see what's there. Wow, look at this. Up at the bend of the plate boundary, we have a big rise that's going with, I would say, with the tide, the normal tidal rise. But looking at this, it also kind of does the same thing, but opposite. It shoots up mainly with just very little. This is on water column height now. There's no wave where it comes in and drops down and then goes back up, or goes up and then comes back down. Do you see what I'm saying? So let's get over to the plate boundary map again. All the way over here, we've got some kind of weird 30 meter whatever going on there. And then over here, a little blip up here at the pinnacle. That's where we get some kind of strange, kind of big break, but on the opposite way. It's going up. So if this was going down and this one's going up, maybe, or maybe this one's going down and this one's going up. Maybe I'm reading it the opposite way than I'm supposed to. That's amazing. Okay, and then we already looked at this one next to the earthquake epicenter. All right, well, let's look at the one in between. A little blip on there again. Just a little bit of movement there. All very interesting. So each pinnacle, at least to the east and to the southwest, at each tip, like a bookend, we got something weird going on with major shifting. Shifting up and shifting down. Or shifting up and shifting down, depending on which way we look at this, west or east. Now, I would like to go over and look at tsunami.gov and see what their warnings are still going for. They do have significant size wave warnings going. Let's go look at the warning and advanced watch and threat level for Canada, for instance. Okay, they say along the coast of Canada, the tsunami threat along the coast of Canada has now passed. Let's go to the most current watch and warning. Tsunami warning remains in effect for South Alaska and the Alaska Peninsula, Pacific coast from Kennedy Entrance, Alaska, 40 miles southwest of Homer, to Unimak. That's the original warning and it still stands. Preliminary earthquake parameters all still show 7.5. And they're saying observed max tsunami height at Sand Point. They've observed this now. An observed tsunami, 2 foot. 2 foot. Now that's a steady inundating wave as opposed to like just a 2 foot high wave that just comes in and crashes and pulls back out. This is more like a surge or a higher tide that comes rolling in. But first that had to pull out. So we do have a confirmed tsunami. We do. There is a confirmed tsunami. Now, across the rest of the Pacific, the good news is that across the rest of the Pacific, this is not going to be affecting anybody across the rest of the Pacific. But around the area where the earthquake struck, again, we're talking about 300 kilometers around the area. Now, people told me that they brought this earthquake up to 7.8. I don't see where they did that. I see 7.5 still. But let's just go look. USGS still has it at 7.5 magnitude. And even though it's a very rural location with no people hardly at all living around the area, for the people that do live in the area, let's just say you're a rough mountain man living out there, you're working in logging or something, 150 people actually felt it. So that's interesting. Now, I would like to go over to the technical details, and I know this is going to get a little boring for some people, but I just want to see what size magnitudes are ultimately detected on the different stations around the area. For instance, local magnitude, magnitude local. Again, these are going to be the local stations around Alaska. They're going to be on land, so they're going to be kind of far away, but we would still see what they're detecting. So, for instance, we would go down the list and we throw out the extreme high end, which is 7.7 and 7.8, but we also throw out the 6s. And then that leaves us with, even though it's far away, still detecting it 7.6, 7.5, somewhere in that mid-range 7 level, which lets us know that their magnitude assessment on this is likely correct. They're not showing us exactly how they come to their determination, what stations they're using or whatever, but we can go to the body magnitude list, which I call the low ball list. Normally this is low, and we're going down the list, and again, we'll do the same thing. We got the same spread. So we would throw out the 6s, we would throw out the high-end 7s, and even on the low ball list, it's still showing mid-range 7s as the predominance of what the stations are detecting. So I like to look at all the stations just to see if it jives with what the person in the cubicle at USGS is saying it is. And 7.5 magnitude, nothing to scoff at, with a wave reported. Now, 2 foot, I mean, that's better than any kind of super large wave coming in, but that's still enough that if you have something along a beach up there, a cabin or something, and it's right there, it could be an inundating wave like a storm surge, like a 2 foot storm surge that comes up on a beach. And if it's at high tide, that can actually be some damaging wave activity. The good news is it's not a 20-foot wave so far. The magnitudes have been rolling up and down. They brought it in at 6.9 when it started. Then they took it up to 7.4, then to 7.5. Then people told me while I was premiering on YouTube it went up to 7.8. But now, again, we're looking at it now and it's at 7.5. We'll see where that ultimately ends up. But it's still mid-range to upper 7 on the red line, which is the plate boundary. And I talk about this so much, but let me show it to you again. Here's the USGS map with the plate boundary. And you see where our earthquakes are up in Alaska. Now you see how this makes a bend over to the east. And I just told you about the buoys that are in event mode here, with some kind of 30-meter displacement over here on the western side, and some kind of 2-3 meter displacement over on the eastern side, and then just a little trickle out on the buoys now is what I'm talking about here. Let's go back over to the buoys. National Data Buoy Center, NDBC. And the buoys now, again, are in event mode in this shape of the plate boundary, making a bend down towards Canada, right? And the big shift from here all the way over to here. But if it's making a bend down on the plate boundary, look which way that goes. That goes into the Juan de Fuca fracture zone, which is already shifting and moving, which we've been keeping track of for the last 2 weeks on the tremor map. This is yesterday's tremors from the 18th. 379 little red dots across the coast of Washington going up into Vancouver Island. Well, it'll be interesting to see what happens in the next few days. Does it die out or does it carry on? I would think it would probably be excited as the plate is shifting all the way from here around and down. If it's shifting at least this far, the next step is right down here where a 4.0 earthquake struck just a day ago. 2 days ago now, actually, 48 hours international time. Right here at the north side of the Juan de Fuca, which the USGS did not report. We had to go to the Europeans to get that info on the 4 that struck right here. But anyway, it's at the pinnacle tip of the Juan de Fuca, and the Juan de Fuca is certainly shifting when we go check the tremor map, and we can see hundreds of tremors per day for the last week and a half, almost 2 weeks, thousands of them. And the professionals came out and announced that an ETS, an episodic tremor slip, is taking place across the Pacific Northwest United States, which is the plate shifting in a pocket or a burst. So the U.S., North America, plate is shifting, pocket or burst. Here, 2 to 3 state region, well, 2 states and Canadian province, Vancouver Island, Washington, and Oregon, that it's shifting here, and now we just got a break up here to the north, up in Alaska. And the break in Alaska, right along that plate boundary that I talk about all the time, that's the superhighway for the energy to travel into the United States. Which then, if you want to know where it's going to go, we watch the arrows, and one big arrow goes down through California, the others point over to the east, over on the edge of the North American craton. So we should see a dramatic increase in activity down in the North American craton over the next several days, including in California, where I already have the warnings going. They expire basically tonight. I'll extend them for 24 hours, but the warnings expire tonight. And now, people are asking me, did I issue a warning for this? We have to go back to last week. I'm 4 to 5 days late. If you go with international time, I'm 5 days late. So I'm 5 days beyond my warning that I had going for Alaska for this past week, where I, quote unquote, struck out. Right? So I'm 5 days late on an earthquake that's the biggest in 90 days or more in the last 3 to 5 months in the North Pacific. And is that an earthquake miss? Well, I would say if I'm trying to get it down to the time frame and I'm 5 days late on a big earthquake like this, yeah, it's a hit. It's a hit. It's not a miss. But if it got any longer than that, like I wouldn't wait weeks and weeks. Like if we got 2 weeks out from now and the same earthquake hit, I'd say, no, that's not the earthquake that I forecast for. So it's just a matter of time frame. It's the rules I set anyway, so they're kind of just have to put a time frame on it, and there it is. So we are just a couple days beyond the warning, and there's our large earthquake up in Alaska. I'll have to go back and get that video. It's on my YouTube channel if you want to go see it if you're a new viewer. So I record all of my warnings in video live before an audience and save them on YouTube, usually, so people can watch them back. Anything else going on? I don't think anything else is going on. They haven't adjusted the magnitude yet. We could go over to social media and try and check and see if people are making, like, video posts. But I'll say the chances of people even being up here along the coast probably are not, again, there probably isn't anybody that's going to be affected directly by any tsunami directly there. But somebody's witnessing something. They have National Weather Service monitoring stations along the coast, so, they do have people there to monitor. Okay? Word up. Much love. I'm going to save this as a video, and I'll be back if anything else goes down. Peace out. Hold on. Everybody hold on. Look at the chat room scrolling on the side of the screen. This is what Twitch is great for, by the way. Let me just give a shout out to everybody who's watching live over on Twitch, because I can't stream usually over on YouTube. They shut me off the last time I was on live on YouTube. They shut me off straight up in the middle of the update. And I was still live everywhere else. It was just YouTube that killed it. And I went live on YouTube trying to do Earthquake 3D, and they limited me to 50 live viewers out of how many hundreds of thousands of subscribers do I have? 400-something thousand? Okay, well, out of 400,000, 350, wherever it was, they wouldn't let me have more than 50 live viewers in my stream. And I said, you know what? They're not allowing me to stream here. So Twitch has been very generous and very kind. And there's actually people on the staff who get updates who live up in Alaska, actually. And, it's great that they allow science and discussion of things that are somewhat, science controversy isn't really that big of a deal, but, so we can't stream on YouTube, and that's troubling, but there it is. So people are telling me that I need to go check the buoys again because Hawaii is showing up. Well, that is extremely interesting. Let's go see what's up. Wow. Did I just miss that the first time? Was I not seeing that? Was I too busy focused here on Alaska to not see that there's a buoy in event mode in Hawaii? Now, these buoys can be sensitive to seismic activity a world away, but in this case, it's actually got a pretty nice size event mode going on with itself. Now, this is measured in points of a meters, so in other words, the ocean there is very still right now. Do you see that? So this is the ocean height coming in. It's very, very still, just a few small waves, just a few points of a meter. And then, boom, all of a sudden, we've got our incoming shock wave from the earthquake, most likely, going across the plate. That's not an actual spread of a wave because it spreads at the speed of a jetliner. It takes 5 hours or more, I think, to fly from Alaska to Hawaii. So the wave itself from the earthquake, or the actual wave in the water, wouldn't be arriving in this location yet, which means that this is the shock wave from the earthquake being detected on the buoy, but the reason it's being detected there is for some weird reason. It's on the south side where we're getting a reverberation coming around the big island of Hawaii. Look at this. Hold on, man. This is just weird. This is just weird. to get it that far away. It means the whole plate is shifting. Let's zoom in on it. Go find out the actual spot. Oh, we can go look this up on Google Earth. Let's do that. Let's get the buoy coordinates. Do they have them? Hold on. Let's go see if we can get buoy coordinates. Yes, they've got the coordinates. Yes. Let's get the coordinates and put them in. So we can see exactly where the buoy is. Perfect. Did I just do a Napoleon Dynamite? Yes. Oh, man, no. No. Okay. All right. Can't win them all, guys. There we go. So here we are. We are on the west side of the big island of Hawaii in a spot that I've showed you several times before, right here. I showed you these hundreds, well, actually, there's probably even thousands of undersea mount volcanoes. These are little spatter cones that form across this. And these are, again, part of an undersea volcanic field that I don't have a name even downloaded from the USGS or Smithsonian to mark it. But it's right next to the Alika Knoll in the Indianapolis Seamount, an undersea volcanic field. And we're right on the edge of it. But let's look at this in a trajectory across the Pacific to really understand how this just happened. So up here, across the north side of the plate boundary, this is so interesting. This is happening. So here on the red line, up here, we have the shift, which you can see on the buoys. Let's get back over there and look at the buoys. Going from the central Aleutians all the way over and up and around and down towards Canada. Again, remember that shape because it matches this shape, the plate boundary. But now, out here in the middle of the plate, we have this buoy in event mode off the southwest coast or the western coast of the big island of Hawaii. How could that happen, right? Okay, let's go over and show you now on my map here, which is going to be a little bit easier to see. Let's get all the earthquakes out of there. So big shift up from here, around and over and down. And right out here, you see the island chain of Hawaii. Now look where it connects into. Connects back like a V shape or a Y shape, and it goes here to some undersea mount volcanoes. This is Temu Massif, the largest volcano, I think, on the planet. If not the largest, the second largest. But we go up and you connect into another series of undersea mount chains that goes back up to the Aleutian Island chain that just shifted out to the center. And it goes back and meets with Kamchatka. But watch from a greater angle. Look. Coming out of Kamchatka. Let me make sure you can see all this. Coming out of Kamchatka, going down and branching off to Hawaii, and dead ending at the Big Island. But you can see it carries on, doesn't it? The undersea mount chain goes down to the east by southeast and carries on. And makes a C-shape, crescent-shaped bend and goes over and comes into the south point of Peru in South America. Now, a push has already come across all the way down, and it's been detected. That's, again, the event mode tells us what was detected, and that's the earthquake. But that's not a seismograph there. I mean, it is a seismograph built into the buoy, I think. I'm pretty sure. But still, for only one buoy there to pick it up, it's at that volcanic field. And that volcanic field ties into the underside, I think, of Hawaii overall. Let's go back and look this way now. The volcanic field here ties into the western side. You see how it comes up and goes into just the main big island. I would think that a reverberating wave coming across, going at least as far down as Hawaii, has taken place. A large shift has taken place on the plate boundary up to the north, and that's shown by all the buoys moving with that 30-foot thing. Here, let's go back and look at that. That part is just too weird. Let's go out here and look at this again. This drop-off. This red drop-off. The event mode. Look at the event mode compared to the regular wave mode. Same time. But it drops off overall. I mean, it drops off, comes back up, goes over, drops back down. That's the event mode. Then it comes back up, it looks like, or the expected wave height comes back up. But the drop-off is from, listen to this, 5590 meters down to 5575. 15-meter drop. That's what it officially is. Then the second drop goes further. It goes about 20-something meters, maybe 25. 20. So let's just say between 15 and 20-meter drops occurred, And then, of course, there's 3 feet in a meter, so what, 50 foot? 60 foot? And then it comes back up. But I just wonder, where did that come from? Well, we know that the plate boundary is there, and that's the shift on one side. But we shift up to the east by northeast on the plate boundary up to the east-northeast at the Pinnacle Bend here, and look, it shifts up only for the most part. I mean, there are a few downturns in it, but I mean, you can see it. It's going up with the rising tide. So this would be rising tide of 1 meter, 3 feet. Or is that is the plate rising right now? And this is something else that we don't normally see. But this is the event mode as it was recorded. So I think that would be rising tide. I hope that's rising tide. You have to assume and err on the side of caution that would just be the rising slope that would happen over the course of a day, several hours as tide is coming in. Hopefully. If not, then the plate is rising itself that much along with the event mode, which is even weirder, and I don't think that would be taking place. But nonetheless, it's still an event mode going up overall. The predominance of the waves, you see how it's detected, and I think that would mean that again, this is wave height, so we're not talking about earthquakes now. We're not talking about looking at a signature of an earthquake. This is the wave column height, the waves itself, the ocean itself, the height of the ocean. And so it's doing that here at the Pinnacle tip to the northeast and to the southwest. Then we get the buoys going out in event mode out in Hawaii next to the volcanic field tied into the chain where the wave's going to intersect. This is now the shock wave of some kind, if you want to call it that, from the earthquake that travels faster than a tsunami. Because the tsunami is going to travel at the speed of a jetliner. So it'll take several hours to get down here. It's only been like 2 hours since the earthquake. There's no way it could go that fast if it's the tsunami wave. And we'd have more stations detected, not just one. So some kind of shock wave goes across, and that buoy above that volcanic field goes into event mode because for some reason that volcanic field got experienced an effect from the incoming shockwave, which is tied to this chain of volcanoes, which is the Hawaiian Island chain, that goes back up and ties into the Aleutian Island chain overall. So if all this just shifted, it stands to reason there's going to be something that comes down and goes over, right? This is all tied together overall. And that's what's going on right now. So they are reporting smaller earthquakes now, by the way. I mentioned that in my update. There should be hundreds of smaller earthquakes striking in here, 0s, 1s, 2s, and 3s. And they're showing us now the 2s and 3s mixed in with the 4s and 5s. And it's going to ding off like this. I would expect it to. And then it's going to transfer over to the United States. The energy out of this. So with this amount of energy deposited into the North American craton, it's a good time if you live on the West Coast to, well, update your emergency plans. Get ready for the forecast that I've issued to be a couple days late. That's all, I think. If anything changes, I'll get back on and cancel it. But right now, we're on the last day of the warning for California, and this just happened up on your northwest side of your plate boundary. Let me show it to you again so there's no disputing this. That up here is where the energy came in, and the buoys reflect that something shifted all the way over to Canada. Look at it again. The buoys in event mode go all the way over to the east with that little blip on the easternmost, which goes right into the northern part of the Juan de Fuca fracture zone. We're just a hop, skip, and a jump now from where the buoys in event mode to the tip of the Juan de Fuca, and we had a 4.0 earthquake there 2 days ago at the north tip while all this is shifting on land. I think this is going to dump more energy into the plate, and it's going to either super increase the slow slip or we'll see it completely go away. But now that I know they're listening, they'll probably just keep populating a few hundred. Whichever way we want to go. The plate is either going to continue to slip when the energy comes in, or it'll be enough of a push that it's blocking the whole thing up into the northern side of the Juan de Fuca. The whole thing, I'm talking about the energy coming in from the plate boundary, blocking this from flowing in. But right now it's shifting. So I would think the shift would increase as energy is put into it. But we don't have any other previous examples, at least on the west coast of the United States, that I can go on in recent memory in the last 10 years, where we have a slow slip happening up here on the northwest, and at the same time, just a little bit further up north, we have a big push that takes place, or a big break that takes place on the red line on the plate boundary to the north. What happens when they both happen at the same time? That's a good question. We have to wait to see. Now, there's other things that have been going on up here. For instance, in the northwest, up here, we've had the slow slip. We've had the hot spots that have appeared. Going up to Canada, we had hot spots appear right in the middle of this location, to the east of the Hecate Strait. It's called Goose Island Volcano. Never heard of it before. So that was interesting to happen a day ago. Hot spots here. And the buoys going into event mode right down to it. Let's go look again one more time. Let's see how close we are to the Hecate Strait. Here's Haida Gwaii and the Hecate Strait. Over here is where our buoys were in event mode, or where our hotspots came into, and the buoy in event mode to the west, right out here off the coast. It can't be chance or coincidence when that matches with this, the red line, the plate boundary that's in motion. And if the plate boundary is in motion here, and we know that it's shifting on land down according to the Pacific Northwest Seismic Network. We can go over to their tremor map. Down here in Washington and in Vancouver Island with all these little red dots where the plate is shifting as of yesterday, 379. If this drops off, I would think something big is going to break out here in the ocean. If this picks up and there's more or carries on the same, I would think that that would lead to new activity down in California and over east on the edge of the Craton. And ultimately, both are going to lead to activity on the edge of the Craton. It's just one's going to be taking preference over the other. And I would think the new push that's coming in is going to take preference and take over the situation and maybe even put more into it. I hope I'm wrong. Speaking of being wrong or right, it doesn't matter whether or not you're right or wrong if you don't have an earthquake plan and survive an earthquake that you could have known about that was coming. And the reason I bring that up is we have the arrows on the map here showing which way we expect the overall flow to go. This is from about a decade worth of observation. Now, I've had the arrows on the map and we've slightly adjusted them over time as we paid attention more, but they all point in the same general direction. They come from the West Pacific, spread at our break in our plate boundaries, reaccumulate north of Japan, come back over and go back into the United States North American Craton. Energy also goes over to Europe, spreads across Asia, follow the arrows. Ultimately tries to make its way to the Mid-Atlantic Ridge. And energy travels from here across the fracture zones, which are east and west facing. They look like almost latitude on a map almost. But they go over to Central and South America, where the energy breaks around the plate in two directions, to the north and to the south. And it bends and curls around the plates. Look at the earthquakes over last week. Goes along the coast, bends up to the north, and around over to our X's to the north, right in between them, which was the forecast for this past week, to not hit at the X's, but to hit in the middle, in between the X's. And then down to the south, same thing. Spills down and around and bends over to the east, following our plate boundaries in both directions. So the plate boundaries are like super highways for the energy to travel around the planet, and that's why I pay so much attention to where the red lines are here on the USGS map. But the arrows that we've put on here tell you which way to watch. So you can watch this flow into the United States over the next few days. And now that we're dealing with mid-range to upper 7 activity in the North Pacific, well, we have new deep earthquakes popping off over in the West Pacific. See our letter D right here? Letter D stands for deep earthquakes. We have a few of them on the map. 1, 2, 3. We have another one up here at Japan. And another one up here at Kamchatka. All the way over in the Middle East, we have one. And we have one all the way down here in South America. And the earthquakes that are raised high off the globe are where our deep earthquakes have been reported by the USGS over the last, and Europeans, over the last 48 to 72 hours. And you'll see our letter D here, right on it, deep earthquake, right down below it, forecast area hit. Our letter D here, hammering off several times like a stair step coming up from down below. These deep earthquakes that are raised high off the globe here on our letter D. We come over here and on our other letter D. It's kind of hard to see, but there's so many earthquakes on it, but there it is, a new deep 5. We go up here to the north and we have a letter D, or up to the north at Japan, but the earthquake is on the Izu Ridge south of the letter D. So our letter D is here, but we have a deep quake hammering in on the underside of the plate. Down here to the south, more rare, doesn't happen very often. But we go back down to the south here, and that's where the big hammering action came in a week and a half ago with a deep 6 that came hammering in on the underside of the plate here, which displaced Australia, Central Australia, Southwest Australia, Southeast Australia, Northeast Australia, and Tasmania. It also displaced over to the west, and I haven't even talked about the increase in 5 and 4 activity across all of Indonesia in the last day and a half. It was quiet. There was no activity in Indonesia. Now it flared through the roof over the past 2 days. But everybody's concerned about this, and I am too, with the tsunami warning that comes in. Now, the 2-foot tsunami warning is good news. The buoys in event mode are the more concerning thing. That tells us about what's going on with the shifting when the water height actually is changing at these spots. So if the water height changes 30 meters, 20 meters, am I exaggerating that? Yeah, 15 to 20 meters. 15 to 20 meters. Drop. And then it goes boing and comes back up. And then it drops again. And then it comes back up again. That to me would say that something shifted on the plate boundary. The water depth here is 5,618 meters deep. It's like 15,000 foot depth. So it's down towards the bottom of the plate boundary, right where the seafloor is. Obviously, it's anchored to the seafloor. But it's over here, like at 15,000 foot depth somewhere. So somewhere right about in here on the edge, the slope going up. And if it shifts there, and it shifts all the way up here at the Alaskan border with Canada, that to me says that 1,000 miles, how actually is that 1,000 miles? Let's go see. From Central Aleutians, now I can't measure the bend really, or can I? Maybe I can. From here to here to here. Yeah, I can. To here. To here. It's just a rough approximation. It's going to be off by a few miles. (1,838 miles), or in kilometers, it's 2,959. So it's a heck of a long distance that just shifted. And how many miles is it all the way out to Hawaii? What if it's the same? Should we measure? Inquiring minds want to know always, don't they? Okay, so let's go. I want to find out too. So let's just go look it up. The earthquake striking right in here. I have the coordinates marked where it says 7.4. Need to change that to say 7.5. And let's measure all the way down here to the big island of Hawaii to that volcanic field. Is it more than 1,800 miles? 3,800 kilometers and 2,400 miles. So that's a huge area to experience a shockwave effect picked up by buoys and shifting that much. 30 meters on one side, or 15 to 20 meters. 15 to 20 meters on one side. That's huge. That is huge. So I'm going to save this. Got to save it as a video right now. We will upload this again over on YouTube and premiere it so everybody can watch it back on YouTube. And again, guys, I would stream to YouTube, but last several times I was on, everybody saw it. I got kicked off on YouTube while I was still live on all the other services. And it wasn't a chance or coincidence when they reduced my live stream down to 50 live viewers. I said, I'm done. And that was after they had changed my other stuff to all say 187. I mean, so, a long story on that, but yeah, we had to get out of there. It wasn't allowed kind of thing. But they'll allow me to premiere usually sometimes, as long as it's not controversial. There's the information. 7.5 big earthquake aftershocks are taking place, and they will continue to take place until energy transfers out over into the North American plate on the craton. We will know it when our earthquake numbers and magnitudes dramatically increase. Right now, in the United States, on the West Coast, we are at the 3.0 range. Just take a look. Last 48 to 72 hours worth of earthquakes. Central Idaho, 3.4. Eureka, California, 3.4. Southern California, down at the border with Mexico, 3.5. A 3.4 out here in the Mojave Desert, which we already just looked up in the previous update, out at a volcanic field. And a 3.2 right over at the border. So it's a bunch of threes. And I would expect this to go up by at least a magnitude everywhere where we see these threes. Well, that's pretty much where we have the warnings going for the fives and the upper fours, Upper 4 to 5.0 warning, which expires today. And we got mid-range threes Instead of upper 4s to 5s, I'm a magnitude and a half under at every single spot. It's so weird. So 1.5 magnitude at Eureka under, 1.5 magnitude in Southern California under, 1.5 magnitude at Ridgecrest under. There's only one spot that hasn't shown any activity where I was expecting it, and that's where all the rings overlap. That's here at the North Owens Valley. Along the Owens Valley. The rest of the spots have moved. So the spot here in the middle where the rings overlap is the only spot I would still expect to move. But magnitude-wise, again, we are 1.5 under what I'm expecting. So I think it's still going to come in, especially now that a new push has been generated up in the Northwest. New energy has been put into the plate, which means it's going to be coming our way. Now it is time to save this and upload it over on YouTube, okay? Peace out, guys. Word up. Much love. I'll be back.